Our lesson today is collisions. Let's talk about the types of collisions. We have 3 types of collisions. The first one, elastic, inelastic, and perfectly inelastic. So we have 3 types: elastic, inelastic, and perfectly inelastic. Let's talk about the difference between elastic or inelastic. An elastic collision loses no energy. The deformation on collision is fully restored. What's the meaning of deformation? Deformation is like changing size, changing the shape. This is the meaning of deformation. So if you have 2 balls, they are collide with each other, and this type of collision is elastic. After they are collide, after they leaving each other, there's no change of this shape, there's no change of the size, they can be restored. This is mean elastic. The inelastic, as you see here, the 2 cars, the inelastic collision, the energy is lost and the deformation may be permanent. It can be restored or it cannot. So it may be permanent. How do you know? Put your finger, click on the place where they are collide. If you put your hands in the things that restored, this is an inelastic, like 2 cars here. They are collide. You put your hand on the door as an example. Then you remove your hand. If they change that are restored to the origin, this is elastic. If it is not, this is inelastic. Like the what's his name? The dough. When you make a bread, this is the meaning of it. If you put your hand and the dough, it's return or it's restore its deformation, it's restore its size, it's restore its shape. This is elastic. If it is not, this is not elastic. Is it clear?
Yeah.
Teacher, it's kinetic energy, right? Like specifically kinetic.
Yeah. This is if you talk about energy.
Teacher, can you repeat elastic?
Okay, but let me write it. Let's understand the word of elastic. In Arabic, it's mean marin.
Oh,
Okay, to understand it. Elastic, like imagine you have 2 balls. When they are collide with each other, try put one in the right hand and the one in the left hand. Collide them with each other. اخبطيهم هيك ببعض. What will happen? After they collide with each other, they will go to the other sides, but the shape of each ball will restore.
Like you mean they will be the same?
Yes, they will come back to the origin. They didn't change its size or its shape.
Oh, from its name, Marin. Okay.
Yes. But that's I told you the dot. I mean العجينة.
Yeah. Okay.
Okay. This is the meaning of elastic. Now, in elastic, that's as you see here when these 2 cards are collide with each other. Now let's talk about elastic. A collision in which 2 objects move separately with different velocities, but no permanent deformation. I have 2 balls that they are colliding with each other. After they colliding, one of them go to the right and one of them go to the left. Okay, with different velocities. Maybe the first one go with 2 meters per second and the second one go with 3 meters per second with different velocity. But there's no permanent deformation. This is the meaning of elastic. They are 2 objects collide with each other, move separately. Okay, they didn't stick with each other, They move separately with different velocities, but no permanent deformation. Like this picture here. Before, as you see, the red ball is collide with the blue one. After collision, both of them, look at them here, they change their they change their direction, one to the right and one to the left, with different velocities according to their masses. And look at the shape of each ball. How did they have the same shape? They don't have any permanent deformation. This is the meaning of elastic. Is it clear?
Yes.
Yes.
Yeah.
Now let's see the inelastic now. Inelastic, a collision in which two objects deforms. So we have a deformation. We have a change in the size or the shape. Like imagine that you have a car that's collide with other car. What will happen here? The objects move in same direction. Like there's a car that's moving to the forward, and there's another car that's collide with it. Both of them will move in the same direction, but in different final velocities. Why? Imagine that there's a car that's moving on the street, and there's another car that's collide with it. So what will happen here? The first car will make an affection deformation of the second car. The shape of the second car will change because you make an accident. Then what happened then? They will move. Both of them are moving with different velocities. When they are collide with each other, they are moving. Both of them, they are moving in the same direction with the different final velocities.
So here the
Why?
moment
Because they are collide, so they change their final velocities. This is inelastic, and the shape of the car will not come back or will not be restored until it can be fixed by mechanics. Sorry. This is the mean of inelastic. Like this picture here. But here, look at these two balls, how they are colliding with each other. After collision, they are moving in the same direction with different final velocities. This is meaning of inelastic. Hala, when we have examples, you understand, inshallah. Perfectly inelastic, that the two objects stick together. The first one, the elastic, they move with different direction, to the right, to the left. The inelastic, they are moving with the same direction, but same direction with different velocities. Perfectly inelastic, they are stick together and move with the same velocity. Let's now,
like conservation of momentum.
like look here, these two balls, they are colliding with each other. After collision, they stick with each other, then they continue moving with the same velocity. So elastic, inelastic, perfectly inelastic. The elastic, they are continue moving in opposite direction or in different direction. The inelastic in same direction. And the perfectly inelastic also in same direction. But the inelastic with different velocities, but the perfectly inelastic with same velocities. So both of them, they are moving with the same direction. the perfectly inelastic. But the inelastic, they have different velocities, but the perfectly inelastic, they have the same velocities. I will give you now more examples. If you didn't understand, I will come back. Now, for each of the following examples, identify the type of collision. Look at here now. You have a white car or silver car that is moving to the right, and there's another car that's moving upwards. They're colliding with each other. What happened after the collision? The car the silver car lets the blue car move to the right. So the first question, are it's an elastic collision? Is the car after the collision remains its shape?
No.
No, so it's not elastic. So it could be inelastic or perfectly inelastic. Now look at them now. Are they stick with each other?
Yeah, and they move in the same direction. So
yes, they are stick with each other. They move to the same direction, so they are perfectly inelastic. Is it clear?
Yes.
Yeah, another example. Here, you have a ball with a small mass m, and we have another ball with double its mass. After collision, look at what's happened here. Look at the velocity. We have v1. But after collision, we have v prime. I mean, we have another velocity. Now, they have after collision. What did they happen with the two balls?
They stick together.
They stick together. Exactly. They are moving with the same direction. So this is a perfectly inelastic.
This is inelastic?
Yes.
But teacher, like, okay, the photo shows that the ball changed the shape, but like the ball are elastic, right?
No, look at the second ball. She stick with the first one. The small one, she stick with it. And they change its shape.
They are not elastic.
So any things that they are stick with each other, this is inelastic.
Yeah, okay.
Now look at this picture here. Here we have the gun, as you see the shot. Now they are collide with each other. The gun go to the left, and the shot going to the right. With different direction. Which type of elastic?
They are not perfectly because they move in different directions.
So which is?
It's elastic.
It's elastic. Yes.
Without perfectly, yeah.
Here we have in different direction. I told you inelastic in the same direction. Different direction, so it is elastic collision. This example here. There's a lorry that's moving, and there's an apple as an example that's thrown down on the lorry. After the collision, as you see, the apple stick with the lorry. They are moving with the same direction. So which type of collision?
Perfectly
inelastic.
Elastic. It has perfectly inelastic, exactly. This one here now. There's a bus and there's a yellow car. Both of them, look at them here. The mass of the blue is 5, and the car is 4. The mass of the blue is 5, and the yellow is the velocity is 5, and of the yellow is 2. After collision, look here, the blue car, it was moving with 5, it will move now with 3 meters per second. The yellow car, it was moving with 2. After collision, it's moving with 4.5. Look how the velocities now are increased. Now, which type of collision? They are the first step. They didn't move in different direction, so it's not elastic. Are they stick with each other?
No.
No. So it is inelastic. It's not
elastic.
perfectly, and it's not elastic. Yes. Now look at these two cards here. Both of them are moving. They are collide with each other. Which type of collision?
Perfectly inelastic.
Perfectly inelastic. Exactly.
Teacher, the one that you said before was inelastic.
Which one?
The car.
The cars
two
here?
cars. Yeah.
Yes, it's inelastic.
But teacher, they didn't stick to each other.
Yes, they stick to each other. This is perfectly inelastic.
Oh, but in the same
Or
direction.
we have three types, but they are moving with the same direction, but they are not stick to each other, so it's inelastic.
Okay, so if they are in the same direction, they are inelastic, and if they collide each other like stick, they are
Stick,
perfectly.
exactly. It is perfectly inelastic. Now here, we have the first box is moving, and the second one it's at rest after collision. The first box stopped, and they collide or they push the second one. Which type of collision?
Elastic.
It is an
It's
elastic.
inelastic because they move in the same direction, right?
It's
No, it's
supposed to be
elastic.
inelastic, right?
No, they
No,
both
it's
move.
elastic. Yes.
The first box is not moving.
But they move in the same direction.
They change the direction, but the second one it's stopped. It's at rest, so it's changed its direction. And the first one it's moving, then it's stopped. So it is an elastic.
Oh, okay. Yeah.
Now let's talk about mathematically problems here. As I told you, as we said yesterday, the conservation of momentum before equal, the momentum before equals the momentum after, because of the conservation of momentum. And each question has a case. We have to think, how can we write the formula? So the first step here, let's read the question. A 50-kilogram girl jumped into a 100-kilogram raft at rest on the water. So what did we have here? We have a raft. Its mass is 100 kilogram, and it is at rest. There's a girl. Its mass is 50 kilogram, jumps with a velocity and to the raft. If the velocity of a girl is 4 meters per second as she jumps. So let's now imagine it here. We have a raft in the water at rest. Its mass is 100 kilogram. There's a girl. This girl is jumping with 4 meters per second on the raft, and her mass is 50 kilogram. After she jumps, the raft and the girl are moving. What is the final velocity of the girl and the raft? So let's draw the picture here. Before collision and after. Here we have a girl that's jumped to the raft. And after collision, this is the raft, and the girl is on the raft. She's stuck with the raft now, and they are moving. Before, the mass of the girl is 50, and the velocity of the girl is 4. The mass of the raft is 100 kilogram, and the velocity of the raft is 0. This is the given. After collision, and the mass of the girl didn't change, it's 50, and of the raft it is 100. But the final velocity of the girl and the raft after they are sticking with each other is changing. What is the final velocity now? Are they moving with the same velocity of the girl? No, the velocity will change. Let's find now the final velocity.
I think since they are always equal, we will make m times
By
v.
the conservation of momentum, we can solve it, right?
Yeah. Let's
Yeah.
see here now. We said that the momentum before equals the momentum after. What happened before? Before we have two objects, the girl and the raft. The raft is moving and live the life, and the girl is jumping. There we have two different objects. The first object, which is the girl, we know that the momentum is m times v. So the mass of the girl times the velocity of the girl. This is the momentum of the girl plus the momentum of the raft. This is now, here we are talking about the girl times the velocity of the girl. So we are talking about the momentum of the girl before collision. And she have, before collision also we have a raft. The raft, it has a mass and it has a velocity. This is before collision. Now after that, what happened? The girl are sticking now with the raft. So they are combined. We have a combination of two masses in one mass, which is the mass of the girl plus the mass of the raft. And both of them now are moving with the new velocity.
Yeah,
We
they just
name
have
it
the same
with
velocity.
V final. Then let's evaluate now. The mass of the girl is 50 times the velocity of the girl is 4 plus the mass of the raft is 100 times the velocity of the here is 0 equals now the mass of the girl is 50 and the raft is 100. So the new object now after collision, we have a mass of 150 kilograms. But these two objects after collision are moving with different velocity, with a new velocity, and we have to find it. After, you see here 200 plus 0, 200 equal 150 times a final. You will find that the final velocity for both of the girl and the raft where they are moving is 1.33 meter per second. So look at the girl was jumping with 4. And the second one is at rest. But since the girl is colliding with the raft, they let it to move. What is the velocity? So look at look at the changing velocity. The girl, she was moving with 4, but since it's colliding, she's now moving with 1.33. And the raft, it's at rest, but since it's collide with the girl, so it starts moving with 1.33 meter per second.
And teacher, if you want to check it if it's true or not, we will make 1.33 times 150, right?
Yes, if it's equal to 100 or not.
Equal to 100.
Yes. Is it clear now?
Yes.
As I told you, each question has it's like a story. It has a case. You have to understand how you write this formula. This formula is different from question to question, from case to case.
Okay.
Okay, so you have to know how can you write this exercise, this formula here. Let's have another example. But before that, do you have any question here?
No, teacher.
No.
Let's now do this one here. There's a 63-kilogram astronaut throws a 5-kilogram hammer in a direction away from the shuttle with a speed of 18 meters per second, pushing the astronaut back to the shuttle. So there's an astronaut, there's a man with 63-kilogram mass. He has a hammer with his hand, and the mass of the hammer is 5 kilograms. He threw it. So before collision, What happened? Before collision, the man has a hammer in his hand. Both of them is at rest. This is before collision. You have a mass of the astronaut times his velocity, but he didn't move, so his velocity is 0. And the hammer is with hand, so it has a velocity, it has a mass, but it doesn't move, so its velocity is 0. So the momentum before collision is 0. Now let's see what happened after that. He threw the hammer in a direction away from him on a speed of 18 meters per second. So he threw the hammer, okay, and other, like as an example, to the right with 18 meters per second. And as we said yesterday, since the momentum of the momentum is conserved, so since he threw the ball to the right, the ball let him go to the left to make the momentum 0. So the hammer is going away with 18 meters per second. Let's make, or push the astronaut to the back or to the left. You can say right and left, or for backward or forward. Now, assuming that the astronaut and the hammer start from rest, they are standing. It didn't make anything. They are at rest. The man, he has. So here we have a man. Let's draw here. We have a man. The man have a ball, have a hammer, have a ball as an example with his hand. Look at the man. The man is not moving. So the mass of the man times his velocity, which is 0, plus the mass of the hammer, okay, times the velocity is also 0 because they are at rest, equals. Here, after that, the hammer go to the left and the astronaut go to the right. That's why we say, that's why we said yesterday the momentum is conserved. Now the velocity now of the hammer is 18, but the velocity of the astronaut is unknown. So after collision, what did we have? Are they stick with each other?
No.
No. So I cannot say M1 plus M2. They are not stick with each other. Both of them are going to different direction. So both of the two masses are going with not the same, with different direction. So the mass of the astronaut times his velocity plus the mass of the hammer times his velocity. They are not moving with the same velocity. They are moving with different velocities. They are not stick with each other. They are going with different direction. So we have to write now the formula of the conservation of momentum as the statement here.
Okay. Teacher, they are elastic, right?
Yes. Then let's now evaluate. Now let's see the.
So that's why elastic and inelastic are important in solving these questions.
Yes, but you have to know. Here you can know. Wait, after that I summarized for you. If it is elastic, which formulas to use in elastic, perfectly inelastic, or you can understand the question and create the formula.
Okay, thank you.
You're welcome. So here we have an astronaut have a hammer in his hand. After that, the hammer going away with a new velocity, and the astronaut going with the opposite direction. The mass of the astronaut is 63, but his velocity is 0 because they told me assume that start from rest. The mass of the hammer is 5 and is at rest. Now look at what happened after collision. After collision, the mass of the hammer is 5. The velocity of the hammer is 18. The mass of the astronaut is 63, but his velocity is unknown. We have to find it. So, as I told you, the mass of the astronaut times his velocity plus the mass of the hammer times his velocity equals the mass of the astronaut times the velocity plus the mass of the hammer times his velocity. As I told you, look at the first one here. From the first one, you can know that they are different objects. After that, both of them are moving with different direction. Since they are moving with different direction, so I have two terms that they are added.
But teacher, before they was having the same direction and the same velocity, so why we didn't say ma plus mh times just velocity?
You can say this, yeah.
Really? Okay.
Yeah. Because they have the same velocity. So then 63 times 0 plus 5 times 0, as we said, equals 63 times the velocity of the astronaut plus 5 times the velocity of the hammer. Then we will, after solving math, we will find that here. Now, the momentum, look at 5 times 18 is 90. So the momentum now of the hammer is 90. And yesterday I told you they have, since they are conserved, so the momentum of the astronaut must be also 90 to cancel them. So 63 here multiply the final velocity of the velocity of the astronaut must equal 90. So after you find that the velocity here of the astronaut is 1.43, okay, that's mean if you multiply 1.43 with 63, you will find that the momentum here is also negative 90. Why? Because the momentum is conserved. So the velocity here is 1.43. But why minus? Because I told you if the hammer going to the left, the astronaut will go to the right. They are going with opposite direction. So, and since the momentum is a vector quantity, it needs a magnitude and direction. It is minus, that means it has going to the different or to the opposite direction. Is it clear?
Okay, teacher. Yeah, it's clear.
Yes.
Yeah.
I have this. I have 4 minutes, 3 minutes. Can I continue this one or no? Okay, I will stop here today. Okay, tomorrow we will solve this problem and another one, and I will give you more examples from your book related, not tomorrow, sorry, next week. I will give you more examples related to this collision here, and I will give you more examples. Here, I think I cannot continue. This is the last step of the last type. That is, we have later on I will explain it. We have a 50 kilogram cart moving to the right with speed, and there's here we have two things. One, the first cart, it has a 15 kilogram mass, and she's moving to the right. And there's another one, like we have two cars. The other one, it has 6.5 kilogram, but she's moving to the left. So both of them are moving, both of them has a mass, and both of them has a velocities, but in different direction. After they faced with each other, after they collide with each other, what happened? The two cars are stick together. So there we have now two masses, They are stick to others, so we can add the masses now, but they are moving now with one velocity. So the mass here is 15, its velocity is 4. Here it's 6.5, its velocity is -2. Why it's -2? Because I told you now it's are moving with the opposite direction. It's not moving with the same direction, opposite. So I have to write the velocity with -2. After that, both of the masses are stuck to each other, so we have to add the masses, but they are moving now with the new final velocity. So we have two bodies before collision. M1 V1 plus M2 V2. After collision, they are stuck with each other. M1 plus M2 times the V final. Is it clear?
Yes, teacher. Teacher, so in this each other, we don't add them like all of them with each other, like M1 plus M2, right?
Before
But they
collision?
are, like before collisions, yes, they will collide, but they still didn't stick. So
Yes,
we want,
they are different objects.
yeah, okay. But then when they collide,
And I mean that maybe they are not stick with each other. So each one has a momentum.
yeah, so after
So
they
you will find,
okay.
Okay, so here, the mass 15 times 4. Here, as I told you, since it's moving with opposite direction, you have to put negative sign. Then after you solving it, you will find that the new velocity, the final speed of the two cars after sticking is 2.18. Is it clear?
Yes, teacher, thank you so much.
Yeah.
Yeah. Here, this is the summarized